morning, 8th grade. We are beginning module 8 today, and that's all about exponents and roots. So our first module, module 8.1, we're talking about the multiplication properties of exponents. Let's look at our learning target. I can find products of monomials. I can find the power of a power, and I can find the power of a product. So a lot of this we have covered in 7th grade. So this is just going to be a little bit more in depth. So let's look at our vocabulary. We have monomial, product of powers, power of a power, and then power of a product. Okay, so let's first talk about what is a monomial. A monomial has only one term. Okay, so please look, a monomial is a number, a variable, or a product of a number and one or more variables like 3x squared, y cubed. Okay, so product of a number and variables, which is one or more variables. Okay, so it has only one term, and that's what I was just saying. An expression that involves division by a variable is not a monomial. For example, a times b divided by c is not a monomial. Okay, so let's go ahead quickly look at what are the examples of monomials. Okay, so monomials, for example, we have 6y squared. Okay, that is a monomial. If I have x, if I have 80, if I have 8x. So these are all monomials. You can see they are one term. Okay, so either you are multiplying a coefficient with a variable, like here, or we just have x, we just have 80. These are all one, it's just a term, one term. Okay, and you know that terms are separated by addition or subtraction. So we don't see any addition, subtraction going on here. So that is why this is just one term, and these are monomials. Okay, and then let's look at examples of what is not a monomial. So not monomials. And the examples for not monomials, I could have x plus 3. So look, now we have two terms. Okay, if I have x squared minus y squared, once again, two terms. If I have x plus 5, once again, two terms. Because terms are separated by addition or subtraction. So that is why those over there are not monomials. But these over here are monomials. So quickly look at the difference between the two once again. And then we are going to discuss the product of powers property. So let's talk about the product of powers property. And in product of powers, if we have the same base, so let's talk about what is a base, what is an exponent first. Okay, so if I have given you 5 to the 4th power, okay, so this is my base number. This is my base. This is my exponent, right? And this whole thing together is called the power. So this is 5 to the 4th power, 5 to the 4th power, because my exponent is 4. That means my base is going to be a factor. How many times? 4 times. This means what? 5 times 5 times 5 times 5. Okay, and then, so let's look at the product of powers. To multiply two powers that have the same base, add their exponents. So if I have this given to me, for example, and I am going to put the symbols for any real number a and any integers m and p. A to the power m times a to the power p. All I'm going to do is take the base, which is a, and I am going to add the exponents, m plus p. Okay, so let's say I was using what I have just written down over here, and I would say 5 to the 4th power times 5 cubed. Okay, so what does this basically mean? It means I just showed you what 5 to the 4th power is. This is 1, 2, 3, and 4. So look, and then I have times 1, 2, 3. Right? So basically, what is this? 1, 2, 3, 4, 5, 6, 7. I have 5 to the 7th power. Because what am I going to do? Because they have the same base, so I am going to add their exponents. And that's basically what this property means. The product of powers is to multiply two powers that have the same base. You just add their exponents. Now, once again, the bases need to be the same. I can't be doing 5 to the 4th power times 8 to the 3rd power and then trying to add the exponents, because the bases are different in that case. So the bases have got to be exactly the same. So I've gone ahead and put two questions on the board, and we are going to use the product of powers in order to solve this. Okay, so let's look at the first one. It is 3n to the 4th power times 4n to the 7th power. So in order to do this, we are going to group the coefficients and the variables. So let's group the coefficients. The coefficients are 3 and 4. Okay, so we have 3 times 4, and then we have our variables, which is n to the 4th power times n to the 7th power. Okay, and so then what we are going to do is we are going to use the product of powers. So I know this is 3 times 4, and if I am having the same base, which is n, I am going to take n, I am just going to add these, the exponents. Okay, and then what is 3 times 4? I get 12. And n, what is 4 plus 7? I get 11. Okay, and so here is my answer. And that's how I simplify it. Okay, let's do the next problem. Once again, we are going to group coefficients and the variables. So my coefficients are 7 and 2. Okay, so this is a different problem. Okay, so I'm going to group my coefficients 7 times 2. Okay, now we know that x and y are different, so I can't just squish them together like that. So I am going to group x with x, and I'm going to group y with y. Okay, so I have x. If there is nothing on the top, that means it's to the 1st power. So we have x 1, right? Or I can just go ahead and group them together. So I have x times x to the 4th power, and then the next step I'll show you the power products, okay? And then I have y squared times y cubed, okay? So here are all my groupings now. Once again, same basis, okay? And of course, that's the coefficient. Same basis, we are going to group together, okay? Next thing, we are doing 7 times 2, and now I'm going to go ahead and use my product of powers. And I know that if x is written, there is nothing in the written over here as an exponent. That means it's to the 1st power. So x1 plus 4, because some of the exponents, right? and then we have y squared plus cubed. So here are my exponents. And then 7 times 2 is 14, and I have x, and 1 plus 4, that gives me to the 5th power, times y, and I have 2 plus 3, and that is 5. So here is my final answer. Please note that you do not have to put the multiplication signs in the middle, because if it's saying 14x to the 5th power, y to the 5th power, that automatically means that multiplication is going on over here. So you don't have to put dot dot over here or times, because this means multiplication. Okay, so this is what the product of powers property is. So here are 2 more problems. Just to practice this, and so let's look at this. We are going to go ahead once again, group the common variables, and we're going to group the coefficients. Okay, so in this we have our 7 times -7, and our common base is going to be n to the 7th power times n. Okay, and so now we are going to use the product of powers property, and we are going to say again 7 times -7, and then I have n to the 7th power, and this means that it is 1, right? And that's why it is n, so plus 1. And then I have positive times negative is going to give me a negative product. So 7 times -7 is -49, and n 7 plus 1, and that is to the 8th power. So here we go, and there is my answer. Same thing here. We are first going to again group the same bases and the coefficients. Okay, so this is going to be 11 times, there's nothing here, it means what? 1, right? So 11 times 1, because that's what the coefficient is over here, and then I have times x to the 6th power times x. So we are grouping our common bases, right? And then we have y to the 6th power times y to the 9th power. Okay, next we are going to use the product of powers, and of course we have 11 times 1, we have x to the 6th power plus 1, we have y to the 6th power plus 9. Okay, so then I'm left with 11 times 1 is 11, I'm simplifying, x 6 plus 1 is 7, and y, and I have 6 plus 9, and that gives me 15. So here is my final answer. So this is basically what the product of powers is telling me. Okay? So here is a word problem. It's talking about product of powers and scientific notation now. Okay? So, stars. The fastest recorded star in the Milky Way galaxy is US 708, which travels at 2,700,000 miles per hour. How far does US 708 travel in 1 year? Write your answer in scientific notation and round to the nearest tenth. And it's giving you the hint that 1 year has 8,760 hours. Okay, so the first thing we are looking at is the speed of US 708. Here. Okay, and I am going to change that to my scientific notation. Remember, in a scientific notation, when I'm putting my decimal, okay, it's got to be greater than the ones place, less than the tens place, right? So this is what that means. So we have US 708, okay, and let's look at the speed of this, and it is saying 2,700,000 miles, right? And so for me to convert this to scientific notation, I have got to do this, okay? I've got to put the decimal after the first place. So it's going to be 2 and 7/10, okay, 2 and 7/10 times is always written 10 to a certain power. So let's look. Since I put the decimal here, we're counting how many digits are behind. 1, 2, 3, 4, 5, 6. So 10 to the 6th power. And there is my scientific notation for this. Now let's look at the hours in a year. Okay, and we have 8,760, and in scientific notation, once again, I am going to write the decimal straight behind this number. So this is going to be 8.76. That's how I'm going to write it. 8 and 7600 times 10 to, since I put the decimal here, how many digits are behind the decimal? Because always the decimal goes behind the first number. Okay, and so we have 1, 2, 3. So times 10 cubed. So those are my two numbers which have been written out in scientific notation. Okay, next thing we are looking at, it's asking the distance, right? So first we did is write it in this scientific notation, and if it's saying how far does it travel in 1 year, I know that distance is rate times time, okay? And we said rate times time because we know that speed is a rate. And for example, if I say 70 miles per hour, so the 70 miles over 1 hour has made that speed into a rate. That is why we know distance is speed times time, and speed is nothing but a rate. And that's why we say distance is equal to RT. Okay, so that formula, distance is equal to RT, because we're trying to see how far does it travel. Okay, so my distance over here is how much? It is 2, and so we are taking these values. Let me go ahead and write it over here. Wait, distance is equal to RT. Okay, and so my distance is equal to, my rate over here was 2 and 7/10 times 10 to the 6th power times, what is the time? 8 and 7600 times 10 cubed. Okay, and then what I'm doing is, again, I am going to go ahead and I am going to combine the coefficients, or not coefficients in this case, the decimals, and then the tens, which are the same basis in that case. Okay, so I am going to go ahead and group those separately. So I'm taking 2 and 7/10 times 8 and 7600, and then we are multiplying this with 10 and 6/10 times 10 and to the power of 6 times 10 cubed. Okay, and then what we're going to do is, once we multiply this, we are getting 23 and 652 thousandths times 10, and we are now going to do the product of powers, and I do 6 plus 3. Okay, and so when I do that, I am going to go ahead, I'm just going to add this over here. Okay, I'm putting it here. Okay, so I get 23 and 652 thousandths. Okay, from there, and then I have 10 raised to the sum of 6 plus 3. So this gives me times 10 to the 9th power. Okay, so since I am changing this to scientific notation, what I will need to do is move this decimal place one more to the left, because I told you it has to be after the first number. Okay, so when I'm doing that, I have got to add one more to this 9. Because this means what? This means that here's my decimal now. Okay, times I get one more because I've moved to the left, right? Times 10 to the 9th power. And then I'm just going to use my product of powers property, and I am going to write this out as 10 to the first power plus 9. And so what do I end up with? I end up with 2 and 3,652 10,000 times 10 to the 10th power. And then if I round it to the nearest 10th, here I know that the 6 is greater. So this is, once I round it, it becomes an approximation. So this becomes approximately 2 and 4/10 times 10 to the 10th power. And there is my answer here. And that's how I solve this. Okay? All right. So the next vocabulary word is power of a power. So if you're trying to find the power of a power, you multiply the exponents. So what I'm doing, let's look at this one. A raised to the m power and the whole thing raised to the p power. So for any real number a and any integers m and p, and if I have this, all I'm doing is multiplying the powers. So this is going to become a m p. So I am just multiplying those powers. So let's go ahead and solve some problems for power of a power. So here are some examples. And once again, to find the power of a power, all we're doing is we are multiplying the exponents. So I am going to take n, and we're going to use the power of power property over here. Okay, and so this is just going to be 5 times 3, and so therefore n to the 15th power, and that is my answer. This is the simplified version. Okay, let's look at this one. And this is, we have x to the 4th power times 2, because this is power of a power. And so I get x to the 8th power. There's my solution. Let's do 2 more. And once again, we have n to the 4th power times 11. And this gives me n. What is 4 times 11? I get 44. And there is my answer. And then the last one, we have x 7 times 3. You're taking the power of a power, so basically you're just multiplying the exponents, and I get x to the 21st power. And that's basically what power of a power is. All right, so let's do the last one, which is power of a product. So the last thing is power of a product. So to find the power of a product, we're going to find the power of each factor and multiply. For example, let's look at this one. We have the power of AB is m. right? So we are taking each factor. What are the factors here? We have the factor is A and the other factor is B, right? So for any real numbers A and B and any integer m, AB raised to the m power is equal to the factor A to the m power and the factor B to the m power. Okay, so basically, once again, we are finding the power of each of the factors and we are multiplying that. And that's what a power of a product is. So let's go ahead and solve some problems on this. So let's look at these two problems that I have written over here, and we are finding the power of a product. Okay, and we're going to simplify each expression. So let's look at the first one. It's saying 3x to the 5th power, y squared, all of that to the 5th power. So once again, we're going to take each of the factors. And the factors are 3, x, and y. Right? So let's go ahead and we are going to find the power of each factor and then we are going to multiply it. So we have 3 to the 5th power. Right? We have 3 to the 5th power. And then we have x to the, we're going to use the what property? The power of product. And so 5 times 5. Okay? 5 times 5. And then I have y squared times 5. Okay? Because we're doing the power of a product property over here. We are using that, okay? And of course, if I am doing this times this, that is power of a power, right? So now, once I have that, this basically means what? This means 3 times 3 times 3 times 3 times 3. Because I am multiplying the base number, which is 3, I use that as a factor 5 times. Okay, so when I do that, I'm going to get 243. And then I have x, and what is 5 times 5? That gives me 25. And y, 2 times 5 is going to give me 10. So I just simplified this. And I got 243, x to the 25th power, y to the 10th power. And here is my simplified version. Okay, let's do this one. Okay, so now, once again, I am going to take each of these separately, and the factors are -5, a, and b. And I'm going to go ahead and use the power of a product where I am separating each of these and I am multiplying it. Okay, so we are going to go ahead and do -5, right? We've got -5. And what is this? Squared, right? Times, we have a, and this means the power is 1, and times 2, because power of a power, times 2. Okay? And then I have, what do I have after that? I have b, and this is 4 times 2. Now, we know that negative times negative is going to give me positive. So -5 times -5, because that is my base, right? And so, and it's squared. So that is why that's going to give me 25. So this is 25. And then I have a, 1 times 2, of course, that is a squared. B, 4 times 2 gives me 8. So this is my simplified version, 25a squared and b to the 8th power. And that is a power of a product. Once again, to find a power of a product, you're going to find the power of each factor and then you are multiplying it. Okay? So let's go ahead and do one last problem on the whiteboard, which is a word problem. So let's look at this one. And here we go. All right. So here's my question. and it's talking about the power of a product and area. Okay, so if the side of each smaller square is x, each square is x. All right. So if the side of each smaller square is x inches and the side of the whole canvas is s inches, then what is the area of the painting in terms of x? Okay, so I know that what is area of a square? What is the formula? Area is equal to side squared, because it's a square. So this is saying length times width. Basically all the sides have the same measure. So side times side, which is side squared. Okay, so now we know that the entire side, so look, we have, this is 1x, this is 1x, this is 2x, 3x, 4x, 5x. Right? So we have, now what is the area? We just said area is side squared. So area is equal to 5x and squared. Okay, 5x, because this is 5x. This is 1, 2, 3, 4, 5 x's in here. And so since 5x is one side, it has to be side squared, so 5x squared. Okay, so now we are going to use, all right, so this whole thing over here, this whole thing is 5x. Okay, so 5x times 5x, that's basically what we are doing. And then we are going to go ahead and we are going to use the power of a product. And so we have area is equal to 5 squared, right, times x to the first power, that's what this is, times 2. And so what do I get? My area is, what is 5 times 5? 25. And x, 1 times 2 is going to give me 2 to the squared. So 25x squared, this is the area of this shape. Okay? And that's basically what this entire lesson is about. So yeah, just remember, you know what a monomial is. There can be only one term, right? And then you're finding the power of a power, the power of a product. And so these are all the vocabulary words that we focused on. You know, the product of powers, power of a power, power of a product, okay? And that is what the multiplication properties of exponents are all about. And that concludes module 8.1. Have a great day, class.